Okay, Chapter 1, Lesson 3, Properties of Addition and Multiplication. We've got a couple of properties we have to discuss. Got to go over some ideas. You might have noticed that when you add or multiply, certain things can be done. 8 plus 3 is exactly the same as 3 plus 8. That works just fine. What doesn't work very well is when you try to subtract. 8 minus 3 works just fine, but 3 minus 8 causes you to have some trouble. They are not equal to each other. 8 minus 3 is 5, but 3 minus 8 is negative 5, because you can't take 8 away from 3 very well. So you'll notice that for these properties that we're talking about, it works great for addition and multiplication, but it does not work for subtraction or division. For the multiplication and division side of it, just think 3 times 5. That's 15, and it is the same as 5 times 3. 5 times 3 is also 15. But if you want to divide 3 times 5, divide by 3, well, let's try something a little more easier. A little easier, not more easier. 6 divided by 2 is 3, but 2 divided by 6 is actually 1/3. It is not 3, so those are not equal to each other. And this property is called the commutative property. Okay, the commutative property. Let's see, Mr. Armstrong. There's an extra M in here. Commutative property. Commutative property of addition and multiplication are very similar. Let's change colors here. Let's see, 5 plus 8 is equal to 8 plus 5. This is addition. 3 times 5 is equal to 5 times 3. That's multiplication. And A times B is equal to B times A. That's algebra. Okay? And whether we add A plus B is equal to B plus A. This is algebra when we start using letters. This is the commutative property of addition, and this is the commutative property of multiplication. Okay, a lot of times we have to be careful the way we say it. We have to go ahead and add all the details so that somebody knows what we're talking about. The commutative property is this idea where the letters or numbers can change places. 8 and 5 can be on the opposite order and still equal the same thing. For instance, the word commute and has to do with going back and forth. Your parents commute between home and work, or home and school and work, and you commute between home and school. You go back and forth, and this is a commute, changing places. This is how this works. Commuting, going back and forth, and it's just one way to help you remember what this property is talking about. The other property we have to talk about is the associative property. Okay, now the interesting thing about that is it's who you associate with, your friend group, and sometimes in 5th and 6th grade that changes, even in 7th and 8th grade, I suppose. You go back and forth. It's not always healthy, but it's something that you do on a learning curve. Adults even do it sometimes. We associate with different people, and sometimes it is healthy. You might have one group of friends that you associate with certain times and another group of friends that you associate with other times, and you don't always mix those two groups up. When we talk about numbers, you might say something like 3 is friends with 5, and you put parentheses around them. And then over here is 4. 4 is kind of by himself. These two are grouped with the grouping symbols, and this is who they associate with. Well, for the associative property, if you add 3 plus 5, you get 8, and 8 plus 4 is 12. So this is equal to 12. And if you change your grouping, if you say 5 is the popular one and 3 decides to be left out, or 5 decides to leave 3 out, and you have 5 plus 4 over here. Now here we added 3 and 5 and got 8. Got 8, and then we added 4 to it, and we got 12. Over here we add 5 and 4 to get 9, and then we add 3 to it. We still get 12. So this becomes 8 plus 4. This becomes 3 plus 9. Either way, we come up with the same answer. And this is a neat property for the associative property, whether we're doing it for addition or multiplication. It works just fine. And it kind of has to do with whether you move the grouping symbols around. Notice that our 3 and our 5 and our 4, 3, 5, 4, it's in the same order around the equal sign. We didn't change the order. That's the commutative property. We're changing the grouping symbols. All right, let's try it with multiplication. 2 times 6 times 3 and equals. So if we have 2 times 6, we group those together. And over here would be, say we have 2 times 6 times 3. All right, see if we can do this. This is multiplication, so it goes faster. 2 times 6 is 12. I put an addition sign here. This is supposed to be a multiplication sign. See if we can change that. Hopefully you forgive me for making that mistake. 2 times 6 is 12, and 12 times 3 is 36. Over here, 6 times 3 is 18, and 2 times 18 is also 36. So as you can see, this is equal to this. This is what the associative property of multiplication shows us. Multiply, multiply. We get the same answer. You can use this to your benefit now and then. Let me see if I can find you a quick example before we go too far. You know, I think I'm just going to make one up. Say we have 3 times. Let's change that. So we have 2 times 7 times 5. And we just, these numbers are just out here. We could use the commutative property to change the numbers around so that we get 2 times 5 times 7. And it might be that we want to multiply 2 times 5 to get 10, and then multiply by 7 to get 70. So this is something that makes it so that we can do it in our head. If we had done it this way, 2 times 7 is 14, and 14 times 5 we can still do in our head, but it's just a little bit harder than 10 times 7. Sometimes changing them around makes things easier. That's the whole idea there. And with the associative property, the same thing can be done. You might have 3 times 5 times 2, and you might say that it might be grouped like this, and you see this and you think, I really like it when my 5s and my 2s are together. So you might just rewrite it with something else being associated, and then you have to do this first. 5 times 2 is 10, and 3 times 10 is 30. If you are like me and you like to get multiples of 10 because they're easy to multiply, it shows you a way to use the associative property quickly and easily. There's one other thing you need to see. They talk about a 0 and a 1 property. And the 0 property is very obvious. You're going to wonder why I even bring this up, but it's important to think about these properties. These properties in math language are important to kind of get them locked down so that we know exactly what we're talking about. For addition, the 0 property just shows you that whatever you add, if you add 0 to it, you get the same thing. 8 plus 0 is 8. Okay, that's kind of interesting. For multiplication, whenever you do a 0, you get 0. And you know this. You've learned this since first grade, since maybe even kindergarten. If you add 0 to something, you get the same number, 8. It's almost like an identity property. And then when you multiply by 0, you get 0. So these are the 0 properties for addition and multiplication. Now there is one property. We had a 0 property, and there's a 1 property. And that's just for multiplication. When you multiply by 1, you know what happens. Say 12 times 1 is 12. It's kind of the identity property. Some books call it that. We'll just call it the 1 property for now. And it's the 1 property of, does it work for addition or multiplication? It only works for multiplication, so we'll call it the 1 property of multiplication. All right. Nice job. I think this video is long enough. We better stop it.